So today's lesson is lesson 5.1, and the objective is to solve systems of equations by graphing. And remember, the solution to a system of equation is the point where the lines cross. So that point is the solution because it will be on both lines. And the problems that I'm going to be doing are 1, 5, 7, 9, 10, 12, 14, and 18. So you can follow along with me, maybe watch one problem and then do several on your own until I get to the next question. So on number 1, we're just going to determine whether the ordered pair is a solution to the system of linear equations. To be a solution, that means that this point is going to be on both lines and the lines are going to cross at that point. So this is a great strategy for multiple choice tests. All you have to do is take your point and substitute it into both equations and see if it makes both equations true. So to figure out if 6, 1 is a solution, then for x I'm going to substitute 6, and for y I'm going to substitute 1, and see if it works in both equations. So let's do that. So our first equation is x plus y equals 7. And when I substitute 6 for x and 1 for y, you can see that it makes that first equation true. That means that 6, 1 is definitely on the line that's created by the equation x plus y equals 7. Now that doesn't mean it's a solution to the system because it's got to work in both equations. So our second equation is 3x plus 4y equals 22, and we're going to substitute 6, 1 into that equation. So substituting 6 in place of x and 1 in place of y, I've got 3 times 6 plus 4 times 1, and we're going to see if that equals 22. 3 times 6 is 18, 4 times 1 is 4, and 18 plus 4 is 22. So since this works in both equations, then 6, 1 is the point where both of these lines cross. So trying our second choice here, we're going to see if 5, 2 is a solution. We'll replace x with 5 and y with 2. So our first equation, x plus y equals 7. Substituting 5 for x and 2 for y, it does make the first equation true. So we know that 5, 2 is on the line created by the equation x plus y equals 7. Let's go ahead and try it in our second equation, 3x plus 4y equals 22. Substituting 5 for x and 2 for y, I've got 3 times 5 plus 4 times 2, and we're going to see if it equals 22. 3 times 5 is 15, 4 times 2 is 8, and 15 plus 8 does not equal 22. So this 5, 2 is not a solution to this system of equation. Now for the rest of this lesson today, we're going to be solving the system of equations by actually graphing the lines and seeing if we can find the point where the two lines cross. Now I want to remind you that there's many ways to graph a line. Let's just be reminded of what those ways are. Okay, so to graph lines, there's 3 different methods that you can use. So you can use 1 or 2 or all 3 of these methods depending on your line. And the 3 methods are, number 1, first method is to get y by itself. And that way we can start on the y-intercept, the b value, and use the slope, the m, remember that number in front of x, we'll use the slope to move to the next point. From the y-intercept, we'll move to the next point using the slope. And then the second method is to just find points that make the equation true. You know, real easy equations like x plus y equals 3. Well, we could find points all day long that make that equation true, like 0, 3 and 2, 1. That's a really great way to graph a line when you have a real easy equation. And then the third method is to find intercepts by substituting zeros for x and y. Zeros are always real easy to use because they get rid of one of your variables and then you just have the other variable to solve for. So you'll use these 3 methods just depending on what kind of equation you have and which one of these three methods will be the easiest for you to use. So I think for number 5, because both of these equations are very easy, I'm just going to find some points that would make these equations true. And I've got to graph these separately because these are two separate lines. For my first line, x plus y equals 8, I think I'll use intercepts. I know that 0 plus 8 is equal to 8, and I also know that 8 plus 0 is equal to 8. So those are my x and y intercepts that I'll graph for this line. So there you can see my first line that I graphed using the intercepts. Now it's time to graph the second line, x minus y equals 6. So I think because this is a subtraction problem, it would probably be easiest just for me to think of subtraction problems that would equal 6. So I know that 6 minus 0 is equal to 6, and I also know that 7 minus 1 is equal to 6. So that would be values for x and y that would make that equation true, and I'll graph those points. So I've got those points graphed, and we can now see the solution to the system, because the solution to the system is where the two lines cross. And those two lines cross right here at the point 7, 1. So the solution to our system is 7, 1. Now just to double check yourself, you can make sure that it makes both of those equations true, just like we did on number 1. We can substitute 7 in place of x and 1 in place of y. So in our first equation, 7 plus 1 does equal 8. And in our second equation, 7 minus 1 does equal 6. So 7, 1 is the solution to this system of equations. So in number 7, we've got two equations, y equals 2x minus 1 and y equals negative x plus 5. Since y is by itself on both of these, I think I'll use the method of the slope and the y-intercept to graph these two equations, since they've already got y by itself. So in my first equation, I know that my slope is 2, or 2 over 1, because remember I need to rise over the run. And I know that my y-intercept, b, is 0, negative 1. So I'm going to use those points to graph my equation. Remember to start on the y-intercept, so I'm going to start on 0, negative 1, and then from that point I'm going to use the slope to move to my next solution. So I'm going to go up 2 and over 1, and that's my next solution. So 1, 1 is my next solution, and I'm going to draw a line between those 2 points. So my next equation, y equals negative x plus 5, my slope is negative 1, because remember there's really a 1 in front of that x. So negative 1 over 1, and then my y-intercept is 0, 5. Again, I'm going to start on my y-intercept, which is 0, 5. Remember, it's on the y-axis, not the x-axis. And then from that point, I'm going to move down 1 and over 1. So there's my next point. And then I'm going to draw a line between those 2 points. Now my lines aren't exactly straight, but I think my solution, and yours will be straighter when you draw this on the computer, so you'll be able to tell. But remember when you're drawing by hand to use a ruler, but I think my solution looks like that the two lines cross here at about 2, 3. So I think that's my solution, but remember I can always double check by putting that solution into my equation. So in place of x, I'm going to put 2, and it should equal the y value 3. So for the first one, 2 times 2 is 4, minus 1 is 3. So that one works. Then let's try the next one. Negative 1 times 2 is negative 2, plus 5 is 3. So it worked for both of those. So the solution to the system is 2, 3, the point where the two lines cross. Okay, so now in number 9, again we're going to graph these two equations, but these are a little bit harder, so I can't really use the method I used on number 5 I can't really think of numbers that I could put in place of x and y. Maybe you can. Think of numbers you could put in place of x and y to make it equal. And then also the y is not by itself, so I really have to use intercepts, or I have to get y by itself to be able to graph these two equations. So that's the reason we have different methods. It's going to depend a lot on the type of equations you have. So I think I'm going to use try to use intercepts and see how that works. So to find the y-intercept, I'll put 0 in place of x. So when I do that, then I've got just negative 4y equal to 12. And so y is going to have to be negative 3 in order for that to equal 12, because negative 4 times negative 3 is equal to 12. Then if I put a 0 in for y and figure out what x is, then I know that x is just going to be 12, because 12 minus 0 is 12. So there's 2 points, so intercepts worked very nicely on the first equation. So I've graphed that first line. Now I'm going to try the same thing on the second equation. So on the second equation, if I substitute 0 for x, that's going to get rid of my x's, because 5 times 0 is 0. And then 4 times something is going to be negative 12, and that's got to be negative 3. So 0, negative 3, again, is a point on this line. Now if I try to substitute 0 for y, the problem is if I put 0 in for y, I've got 5x equal to negative 12, and that's not going to be a nice whole number. In fact, it turns out to be negative 12/5, and that's hard for me to graph. So I'm going to have to think of another method in order to graph this line. So I think what I'll do is get y by itself. Maybe that will be better in order to graph this line. So remember, I want to move my x's to the other side. And so I'll do that and make these negative. So that will be 4y equal to negative 12 plus negative 5x. Then I'll divide everything by 4. And so I've got y equals negative 3 plus negative 5 over 4x. So I know my y-intercept is 0, negative 3. That's my b. And I know my slope, my m, is negative 5 over 4. So I'll use that to graph my line. So remember, we'll start on the y-intercept at 0, negative 3. And then we'll use our slope. So we're going to go down 5 and over 4. And that will be our line. So the point where these two lines cross is right here at 0, negative 3. So that's the solution to the system of equations. Okay, so on number 10, 2x plus y equals 3 and 6x equals negative 3y minus 6. I think on these equations, I think I'll get y by itself to graph. So on the first equation, if I just move the 2x over, that will get y by itself. So my equation is y equals negative 2x plus 3. My slope is negative 2 over 1, and my y-intercept is 0, 3. Starting on 0, 3, I go down 2 and over 1 for my next point. And then I can draw a line. Okay, so for the second equation, I'm going to move my 3y and my 6x. I'm going to switch those because I want my y's to be positive. So I have 3y equals 6x minus 6, and I'm going to divide everything by 3. So the equation is y equals 2x minus 2. And it's negative 6x, so it's going to be a negative 2x minus 2. That means my slope is negative 2 over 1, and my y-intercept is 0, negative 2. So I'm going to graph that, starting on the y-intercept at 0, negative 2, And from there, I'm going to go down to and over 1 for my next point. And then I'll draw a line between those 2 points. Now, as you can see, that these lines are parallel, and they're not going to cross. So there is no solution to this system of equation because the lines will never cross. Now, you may have known that as soon as you saw the slope. Remember, when the slopes are the same as they are in this, with both of these equations, the slope is -2 over 1, then the lines are going to be parallel, and they're never going to cross. Okay, number 12 says solve the system of linear equations by graphing. This one's actually kind of easy if you just remember that x equals 3 is a vertical line, and that y equals -7 is a horizontal line. So for x equals 3, we'll put a point on the x-axis at 3, and then we'll draw a vertical line right through that point at x equals 3. For y equals -7, we'll put a point on the y-axis at -7 and draw a horizontal line through that point. So the point where the two lines cross is right here at 3, -7. So there is a solution to this system, and the solution is 3, -7. And it does satisfy both equations. X does equal 3, and y does equal -7. Okay, on number 14, we're not actually going to find the solution to the system of equations. We're just going to tell what we know about it. We're going to see if these lines are identical lines. It means they're the same line. Are they parallel lines? Or are they just intersecting lines? And here's how you can tell. So identical lines will have the same slope and the same y-intercept because they're the same line. And they will have an infinite number of solutions because, remember, the solution to a system is where the lines cross. Well, if it's one line and another line graphed identically right on top of it, they're going to cross all the time. So there's an infinite number of solutions to identical lines. Parallel lines have the same slope, but different y-intercepts, different starting points. And those lines will have no solution because they never cross. There's never going to be a solution to a system of equations where the lines are parallel. Okay, intersecting lines have both different slopes and different y-intercepts, and those will only cross at one point. So those intersecting lines have one solution. So to really be able to tell whether these lines are parallel, identical, or intersecting, we're going to have to know the slopes and y-intercepts to compare the two. And once we know the slope and y-intercept, we'll know what kind of line they are. To be able to tell what the slope and y-intercept are, we're going to have to get y by itself on both of these equations. So on the first equation, I'll move the 3x to the other side, and that will get y by itself. When I move the 3x, it becomes y equals -3x plus -8. So I know that the slope of the first equation is -3 over 1, and the y-intercept is 0, -8. On my second equation, I'll move the -x to the other side. Then I'll divide everything by 6. So I have 6y equals 1x plus 18. Remember, there's a 1 in front of that x. Then once I divide everything by 6, I have y equals 1/6 x plus 3. So I know my slope for the second line is 1/6, and the y-intercept is 0, 3. So these lines are intersecting lines because they have different slopes and different y-intercepts. And I also know that there is one solution. That means that these two lines are going to intersect at one point. Now I don't know what that solution is unless I graphed it. But that's not what they're asking here. They just want to know how many solutions are there. Okay, I'm going to do the same thing on number 18. I'm going to get y by itself on both the equations. so that I can compare the slopes and y-intercepts, and then I'll know what kind of lines these are and how many solutions they have. On the first equation, I'll move x to the other side. So I'll have y equals negative 1x plus 2, which means that my slope is negative 1 and my y-intercept is 0, 2. On the second equation, I'll also move x to the other side. So I have y equals negative 1x plus 3. So my slope, my m, is negative 1 over 1, and my y-intercept is 0, 3. So these equations have the same slope, but different y-intercepts, which means that the lines are parallel, and there's not going to be a point where they cross. So these are parallel lines, therefore there is no solution to this system of equations.